it's Ashton. For our Week 7 interactive assignment, we will discuss how to make a ferrofluid and why it occurs. The needed items for this experiment include ink toner, a rare earth magnet, and vegetable oil. To create the magnetic fluid, you first pour the ink toner into a cup and add a small amount of vegetable oil, and you stir it until you have a thin, even consistency. You might have to play with it until you get the right consistency, add more or less vegetable oil. And then when it's in a container, it'd be good if it's something that creates a shallow amount of fluid, so not too small of a container, because then it will make it deeper. So like a flat pan or something like that. It's thin, like a glass Tupperware. And then you place the rare earth magnet under the container, and the surface of the magnetic fluid should magnetize and form into spiky needles on the surface of the fluid. There are many things that you can do with this magnetic fluid and the earth magnet. If you pour it over a thin table and place a magnet underneath, then the spiky needle table or in a container, the spiky needles will form on the surface and look like the back of a porcupine in the way that the needles are formed. More like a cone shape, though, with the needle. And then when you move the magnet around, then the magnetic fluid moves with it because it is being formed by the magnetic field of the magnet. With the magnetic field fluid sitting on the surface, you can actually spin it, like with your finger, or by moving the bowl around. And if you blow on it, it will regain its form because the magnetic field is still staying in place. So when the magnetic fluid is exposed to the magnetic field of the earth magnet, the dispersed nanoscale magnetic particles that make up the mixture, that make up the magnetic fluid, will rotate until they are parallel with the magnetic field lines of the magnet. So that fluid is made of a lot of tiny little magnets, basically. And then they are put in line by the strong magnetic field of the magnet. The alignment of these tiny magnets is what causes the fluid to form into the spiky shape. And this makes the fluid look solid, but it is still a fluid. And you can touch it, you can move it. If you take the magnet away, it goes back into a flat top, looks like liquid again, and you put the magnet back, and the little magnets will once again go into that form. And the stronger the magnet, then the stronger that those become as well, the needles, because it has a stronger field lines. This is really cool. I learned about this first in physics, so it's interesting how it connects with chemistry as well. I appreciate all that overlap I've had with my different sciences in this course. I've definitely been able to bring a lot of biology and physics into this course and just piece it all together in my brain, which is really nice. Not just memorizing stuff, really getting a good understanding of the concepts. So I appreciate that, and I look forward to our last week next week. Thank you so much.